Today we're talking about proportions. A proportion is an equation that shows that two ratios are equivalent. In order for it to be an equation, we need our equal sign. So we've got a ratio 2/3, and that ratio is equal to the ratio 4/6. If I would reduce 4/6, I would get 2/3, so I know that they are equivalent ratios. Therefore, together they form a proportion. When we have two quantities that form a proportion, we refer to them as proportional. Cross products is a shortcut way to identify proportions. So if we have a proportion, so algebraically this one is A over B equals C over D, we can multiply our cross products. So here A and D and B and C are our cross products. And if those cross products are equal, then we know that these two ratios form a proportion. So let's try it out on the proportion that we set up here. 2/3 equals 4/6. So 2/6 is a cross product, 2 times 6, and 3/4 is a cross product, so 3 times 4. Both of them equal 12, which confirms this is in fact a proportion. So let's try out those cross products. When we're determining whether ratios form a proportion, we can use this shortcut. So here we had 6/4 equals 8/12. If we want to know if those two ratios are proportional, in fact, we can multiply our cross products. So 6 and 12 are two of our cross products. They multiply to give us a total of 72. And 8 and 4 are other cross products, which multiply to give us a total of 32. So those are not equal. So those two ratios do not form a proportion. They are not equivalent to each other. Let's try another. So here I've got 25/20 and 15/12. So 25/12 is one of our cross products. So 25 times 12. And this will give us a total of 300. My other cross products here are 20 and 15. So 20 times 15, which also gives us a total of 300. So in this case, these two are proportional. They form a proportion. Let's try one more. We've got 4/6 equals 18/24. So one of my cross products is 4 times 24, which gives me a total of 96. And then I've got 6 and 18, which gives me a grand total of 108. These two are not equal. Their cross products are not equal, which means that these two are not a proportion. So cross products are one way to identify proportions, but sometimes we're asked if two quantities are proportional. So sometimes we have to determine whether quantities are proportional. So here we've got X and Y, and they want to know if these two quantities are always proportional. Well, I've got a lot more things to compare than just two ratios. I actually have 4 ratios here. I have a half compared to 3, 1 compared to 6, 3/2 compared to 9, and 2 compared to 12. So when I've got that many things that I'm trying to identify and see whether or not we have a proportional relationship here, I'm going to choose a different approach. I'm actually going to write all 4 of my proportions out. So I have 1/2 over 3. This one's a complex fraction. I've got 1 over 6. I've got 3/2 over 9, another complex fraction. And I've got 2/12. And I'm going to try reducing all of these ratios. So this one is already reduced. This one's pretty easy to reduce because I've got integers here. So 2 and 12 will both divide by 2 and I get 1/6. This one's a little trickier. Okay, in order to reduce this one, I want to first really get rid of my fraction here. Okay, so I'm actually going to double this to get rid of my fraction. And whatever I do to the top, I have to do to the bottom. So getting rid of the fraction is my first priority. So I get 1 on top and 6 on the bottom. 1/6 cannot be reduced anymore, so There I go. There's my reduced fraction. Same thing here. I want to get rid of that fraction in my numerator first. That's my first priority. So I'm going to double this. And I'm going to double this one. So 3/2 are 1.5. When I double that, I get 3. And 9, when I double that, I get 18. This one can, in fact, be reduced more. 3 and 18 will both divide by 3. And in this case, all 4 of our ratios reduce to be 1/6. So in this case, x and y, our two quantities, are proportional because all 4 of these ratios are equal to each other. So x and y are proportional. So we're going to look at one more way to identify a proportional relationship. So here we're given a word problem. It says you swim 4 laps in 2.4 minutes. So let's start by writing that as a ratio. We complete 4 laps in 2.4 minutes. We also can complete 16 laps in 12 minutes. And they want to know if these two times are proportional. Well, I can see just by looking at the top that to go from 4 to 16, I'm going to be multiplying by 4. So I also should be multiplying by 4 down here. So let's check that out. 2.4 times 4 is going to give me 9.6 minutes. This is, in fact, being multiplied by 5 to get to 12. So I'm doing different things to get my numerator and my denominator. So in this case, these two are not proportional. They do not form a proportion.